distinguished lecturers, staff, students, members of the press, they are here, ladies and gentlemen. I'm delighted indeed to present this second faculty seminar on behalf of the Department of Zoology, Faculty of Life Sciences of this university. The last seminar, faculty seminar from my department, was presented by Professor L.A. Elahame, the Dean of the Postgraduate School, with the title, Sowing Seeds in Water. Today, my presentation has to do with the seeds we sow on land. That is the outline of the presentation. Introduction. Sub-Saharan Africa is the poorest region in the world with an average per capita income of $688 compared to $1,717 in other developing countries. For over 30 years, the gross domestic product, that's GDP, growth per capita in the region, that's Sub-Saharan Africa, stands at an average of 0.16%. And this is because production has been dominated primarily by either the agricultural sector or the mineral sector. The mineral sector includes the oil and gas. Agriculture in particular is marked by low productivity with little application of science and technology. Looking at 50 years average crop production in Nigeria, for example, we have values of average growth rate for cereals, fruits, oil crops, and tuber crops of 1.51, 0.56, 0.31, and 0.24% respectively. That is very, very disappointing indeed. Table 1 shows a comparative analysis of the yield of cereals in the largest cereals and some other crops in the largest producing countries in Sub-Saharan Africa compared to the world's largest producers. That is table 1. You can see for cereals, Nigeria is the world's largest producer of cereals and is only about 15.28. That's hectogram. 15,280 hectograms per hectare. But the world average, China is the largest cereal producer in the world. And a hectare can produce 54,497 hectograms. An hectogram is 100 grams. So you can calculate that in terms of tons. So you can see the big difference. 15,280 and 54,497. Again, for fruits, South Africa produces 190,713 as compared to China, which produces 102,497. Now, the reason for this is because South African agriculture is still very much in the hands of the whites. All the apples we eat in Nigeria come from South Africa. That is okay, majority of the apple we eat in Nigeria comes from South Africa. Now, that is because the economy there and the agriculture is still much in the hands of white people. Oil crops Nigeria again is the world largest producer in sub-Saharan Africa, but Indonesia is the world largest producer. Nigeria produces 25,073 hectograms, while Indonesia produces 334,644 hectograms per hectare. You can also see the difference. And for other crops, but I just want to mention that for cocoa production, Côte d'Ivoire is both the world largest producer and the largest producer in sub-Saharan Africa. The importance of this table is to show us that there is a lot of yield gap. A lot of yield gap between crop production in sub-Saharan Africa and the rest of the developed world. Now, when we look at cowpea, I'm going to be talking more on cowpea because that is the crop I have worked on for a very long time. When we look at cowpea production in some countries in sub-Saharan Africa, that is figure 1. We see Nigeria as the largest producer of cowpea, but Nigeria is also the highest consumer. It is not an exporting country of cowpea, but an importing country. Niger is the world's largest producer, followed by Brazil. And you can see other countries, 4 countries in sub-Saharan Africa. Apart from Malawi, all the other Ghana and Burkina Faso, they are in West Africa. Then you have the yield. This is in hectograms also. You can see, although Nigeria is the world largest producer, the yield per hectare in Ghana is more than the yield per hectare in Nigeria. You can see that from figure 2. Why? Because Ghana use more science and technology in their production than Nigeria. And again, there is more stability in terms of facilities in Ghana. And in fact, also government support. There is more protection for farmers in Ghana than in Nigeria. And that is why you see a lot of fluctuation. Because sometimes farmers in Nigeria will not have fertilizer. Sometimes there will be drought or political unrest, like we have in the northeast of Nigeria produces the largest bulk of cowpea in Nigeria. But with the Boko Haram situation, much of that production has been seriously devastated. And that's why you have this very sharp drop between 2010 and 2011. And I'm sure you know what we experienced during that period. Then this map just shows the countries producing cowpea in West Africa and the productivity, the level of productivity. You can still see Nigeria in that bed. Now, the reason why we must worry about this yield gap is because the world population is growing with a projection of 9 to 10 billion people living on Earth by 250. This means that the global food demand will definitely increase, and there will be need for heightened food security, increase agricultural productivity, and improve water use efficiency. And in a global review of the factors responsible for this yield gap, animal pests came second after weeds. And it is important that the factors must be addressed. They must be identified, and sustainable production solutions must be developed so that future generations will have food to eat. And substances that are used in the management of these pests, that is to kill and repel or control them, are called pesticides. And there are 3 categories of these pesticides. We have chemical pesticides, including organophosphates, carbamates, pyrethroids, sulfonylureas. We have plant-incorporated pesticides. Those are pesticides that are within the plant, that the plants themselves produce in response or just naturally as part of their constituents. And these compounds are able to affect the life of any pest that attacks the crop. And we have biochemical pesticides also. And these are genetically modified plants that allow the plants to express some proteins that will protect the plant. Then we have microbial pesticides. And these are viruses, bacteria, and protozoans, or even sometimes nematodes that can be used to control some other pests of crop. Now, two key approaches to management of insect pests are host plant resistance and biological control. Host plant resistance is the selection or development either by traditional breeding or genetic modification, and the use of plants that possess defensive traits against herbivores and diseases. Biological control, on the other hand, is the use of other living organisms to control pests of crops. And these organisms are mentioned: bacteria, viruses, and some other organisms. So looking at host plant resistance is essentially a way of protecting crops from damage by insects with the factors or characteristics of the plant. And these efforts have attracted the attention of scientists and farmers for over 100 years. Now there are two types of host plant resistance. You have tolerance and resistance itself. Tolerance allows the crop to be damaged by the pest, but the crop will still produce optimum yield, acceptable yield. That is tolerance. It allows the crop to reduce the effect of the damage. But plant resistance to insects has to do with either the killing or the reduction in the activity of the pest on the plant. Now, plant resistance to insects has played a major role for several reasons. It is self-sustaining, because once you develop a resistant variety, it will be transferred from generation to generation. You don't need anything to sustain it. And it requires little management. You don't need extra. Once you give a resistant variety to a farmer, all it needs is to plant it the way you used to plant every other cultivar, and it will express the resistance. And it's generally compatible with other management practices, particularly biological control. It's compatible because it is inherent in the plant, and it doesn't cause damage to the natural enemies as compared to broad spectrum insecticides. The reason why many people are running away from insecticide is because it destroys natural enemies. But that does not happen with host plant resistance. And again, it can often yield higher returns on investment. It takes money to develop a resistant variety. But once that resistant variety has been developed, it lasts longer in the system, and the money spent on the development, it will give higher returns than the money spent on developing a synthetic insecticide. Now, plant traits, like I mentioned, are responsible for host plant resistance. And these plant traits can be intrinsic, that is, inside the plant itself, and they are therefore constitutive defenses, or extrinsic. They can be induced by the herbivores, and they are therefore inducible defenses. Now, constitutive defenses are natural barriers that protect plants from invasion, such as disruption of oviposition, that will not allow the insect to lay eggs on the plant. Food search will not allow the insect to look for the food and eat it. Or mating will not allow the insect to mate within the canopy, within the farm setting, so that it cannot lay eggs. Or it will not allow the insect to use the plant as shelter, resting place. Now they give the plant good strength and rigidity. Examples of these constitutive defenses are cell walls, waxy epidermal cuticles, bags, hairs, or trichomes. The hairs or trichomes are usually rich in lignin and silica, and some of these hairs or trichomes can be simple or glandular. I've tried to show some of these hairs, and what we have shown here, they are glandular. They can be glandular or no glandular, but we also have those that are just straight, setaceous. They don't have a kind of ball at the top. They can just be simple hairs, as you can see on the little one, the short one. Those white things that look like dots, they are also cuticular derivatives of the leaves. So they can, epidermal derivatives of the leaves, and they can also serve as hairs that will affect the plant's behavior. Now we look at the inducible defenses, which are actually allelochemicals or secondary metabolites produced by the plant to protect it from herbivores. And these include toxins, volatile compounds, extrafloral nectar, pathogen degrading enzymes, and defense-related proteins. Now, there are three categories of host plant resistance. We have non-preference or actizonosis, we have antibiosis, and we have also tolerance, which I have mentioned. Antizoonosis is a situation where the plant discourages the insect from attack. That is a behavioral response. It discourages the insect from attacking the plant, and this can be through morphological traits or chemical traits. It can release some volatiles that will distract the attention of the insect and will not encourage the insect to land on the plant. Or it can have some hairs or trichomes that will not allow the insect to move freely or even use the plant as a host. But antibiosis is when the insect is able to consume the plant or try to use the plant, and in the process it is killed by some chemicals in the plant. And this has another advantage for some insects, the specialist herbivores. Some specialist herbivores are able to obtain these allelochemicals, these secondary metabolites, from the plant, and they will sequester it into their own body. They sequester it into their own body and use it to protect themselves. And a typical example of this is Zonoceros variegatus, which is the common grasshopper. The common grasshopper is what we are familiar with. It obtains an alkaloid, pyrrolizidine alkaloid, from Tian weed. I'm sure we are all familiar with Tian weed. It is the awolowo plant. You know, Zonoceros love awolowo plant, and they lay their eggs in the awolowo bush. When the eggs hatch, the first three instances, there are about 6 developmental instances of Zonoceros. The first 3 will feed on the flowers and leaves of Promolina odorata. That is the awolowo plant. Unless they feed on the flowers and leaves of awolowo plant, they will not be able to defend themselves in the field on cassava plant. Please, next slide. There is an alkaloid in the leaves and flowers of that plant that they store in their body, and they mix it with foam. I don't know how many of you have tried to handle this insect, this Rhinoceros variegatus. It foams, foaming grasshopper. That's why they are called pygomorphidae. And it smells badly, and it tastes bitter. It is because of the presence of that alkaloid, pyrrolidine alkaloid, that it tastes bitter and smells badly. So it's able to use that compound to protect itself. But general herbivores that eat all kinds of plants cannot do this. Now, phytochemical compounds responsible for antibiotics include non-protein amino acids, cyanogenic glycosides, alkaloids, terpenoids, coumarins, cardinales, tannins, lignin, flavonoids, and polyphenols. And these phytochemicals act by nervous system inhibition, tissue malformation, interferences with protein synthesis, feeding deterrence, enzyme inhibition, growth inhibition, and so on. And all these emphasize the fact that this antibiotics is very, very important in host plant resistance. And it is also true that nutrient deficiency in the plant itself can also cause some of these effects of plant trait present. Now, tolerance that I mentioned before, we allow the plant to still give acceptable yield despite the attack from insects. But some environmental factors can be responsible for this. And I'll try to give an example from a plant, Festuca aerodinacea from New Zealand. It has a fibrous root system. And this fibrous root system is so extensive that it is one of the grasses that survives dry season, drought, because it can muster some water from the surrounding because of the profuse root system. But also this root system has enabled it to support more scarab, ground beetle larvae, as compared to other grasses. So while surviving during the dry season, it also allows more insects of this scarabid family to survive, and it will still produce, it will still give the luxuriant green nature that it is supposed to give during the dry season. Now, it is known that physiological characteristics are responsible for this kind of tolerance. And these include plant vigor, short life cycle, early maturity, ability to replace damaged tissues, ability to regrow or withstand infestation. Now, plant tolerance is very, very important in IPM, which is Integrated Pest Management. But it has not been possible to find a gene that guarantees tolerance in plants. I would like to look at cowpea host plant resistance. Like I said, is the crop that I've been very much familiar with. Now, insect pest damage is the biggest problem in cowpea production. And today, a wide range of insect pests attack the crop. All over the world, there are about 85 of them. But 20 out of those 85 are major pests or important pests in different regions of the world. And it is only by chemical insecticide we can control these insect pests. And there is no way one can grow a healthy cowpea crop without spraying at least twice. Up till now, at least twice, the crop must be sprayed if the farmer wants an acceptable yield. And in Nigeria, the major insect pests include both flower pest, pod pest, and flower and pod pest. The pre-flowering pest, flowering pest, and pod pest. The pre-flowering pests are essentially Apis crassivora and Bermesia tabaci. Bermesia tabaci transmits some viruses to the cowpea plant, but Apis crassivora destroy the plant seriously because it reproduces profusely and it can cause significant damage. Then we have two insect pests that attack the flowers, particularly Megalobotryps zosteti. Is very, very devastating. It can lead to up to 100 crops lost because once it attacks the flowers cannot produce the pods. And also, the Maruca victrata, it attacks both the flowers and the pod. So Maruca again is here attacking the pod and the bug complex, pod bugs complex. We have a lot of them, Praviglara species, Riptortus species, Neisseria fluvidula, and some others. Now, cowpea is very, very important, at least in West Africa. And the yield on farmers' fields, because of these attacks, is usually very, very low, between 100 to 500 kilograms per hectare. And the potential yield, at least at the research station, is between 1.5 to 3 tons per hectare at the research stations. So there is a very big yield gap between what the farmers are getting and what we can get from the same varieties on station. And some lines have been found that are resistant to some of these pests, and these resistance are based on physical characteristics of the crop or the plant itself, as well as biochemical characteristics. We have tried to give some of them which I have mentioned earlier. Next slide. Now, what are genetically modified or engineered crops? By definition, a genetically modified organism is one whose genetic characteristics have been modified by insertion of an altered organism gene. The organism has been altered. It's no longer the same, but the gene is taken and incorporated into a plant. Now, the gene can be taken from a plant of the same species, and in that case, it's called intragenic transformation. But when the gene is taken from an organism of a different species, it is called a transgene, a transgenic modification. Now, I'm sure some of you have heard of The Silent Spring, a book written by Rachel Carson in 1962. That book opened the eyes of the whole world